Today we are testing a standard 24-pin ATX connector. First, ensure the PCU is disconnected from the motherboard. To power it on manually, I have used a paper clip to bridge the green PC on wire to a black ground wire. You will know it's active when the fan spins and the green PCU light glows. As you can see, my colleague is inserting the black negative probe into a ground slot. This is essential to complete the circuit. Voltage isn't an absolute number, it's a measurement of the electrical pressure difference between 2 points. By placing the black probe into the 0-volt ground, we establishing a base level or reference point. This allows the multimeter to accurately measure how much higher or lower the voltage is on the other colored wires we are about to test. Now let's set up the multimeter. To read these voltages accurately, turn your dial to the DC voltage setting. On this meter, I'm selecting the 20 volt range, which is perfect for the 12 volt maximum we expect to see. With our black probe still grounded, we are going to move the red probe systematically through the 24-pin block. We are looking for stability. Even a small fluctuation outside the standard range can indicate a failing capacitor or a faulty rail. As I probe each pin, we will compare the live reading to the nominal voltage. Most rails have a plus or minus 5% tolerance. Let's walk through the primary colors we will encounter. Let's start with yellow wires, which represents the plus 12 volt rail. This is the most critical line for modern PCs, as it powers the CPU and GPU. For a healthy PCU, you want to see a reading between 11.4 and 12.6 volts. Red wires, which provide plus 5 volts. This rail is used by your storage drives and USB ports. Here, our target is exactly 5 volts, with an acceptable range from 4.75 up to 525. If your multimeter shows something like 5.05, that is perfectly normal. Orange wires. These carry the plus 3.3 volt signal, which is vital for the motherboard's logic chips and M2 SSDs. You should see a reading between 3.14 and 3.47 volts. Purple wire. One very important pin. This is the plus 5 volt standby rail. Unlike the others, this rail is always live as long as the PCU is plugged into the wall. It allows your computer to perform tasks like wake on LAN or simply respond when you hit the power button. Its tolerance is the same as red wires, from plus 4.75 up to 5.25 volts. Moving on, we will find the blue wire. This is the negative minus 12 volt rail. This rail is used less frequently in modern systems, so it actually has a wider 10% tolerance. You are looking for a negative value between 10.8 and 13.20 volts. Finally, keep an eye out for the gray wire. This is known as the power good signal. Once the power supply internal self-test is complete and the voltages are stable, it sends a plus 5 volt signal to the motherboard to let it know it's safe to boot. If it reads 0 volt, the computer will never start, even if the other wires looks fine. By systematically checking each color against these tolerances, you can confidently diagnose if a power supply is healthy or if it's time for a replacement. Remember, stability is the key. If the numbers are bouncing around rapidly, that's a sign for a failing unit. Finally, let's check the peripheral Molex connector. You can identify it by the red, yellow, and black wires. This connector provides power to your storage drives and cooling fans, and it's important to verify both voltage rails here. With the black probe grounded, we check the yellow wire for plus 12 volt rail, looking for a range from 11.4 up to 12.6. Then we test the red wire for plus 5-volt rail, which should stay between 4.75 and 5.25. Stable readings here prevent drive failures and data corruption. By testing every lead, you have ensured the PCU provides stable power across all rails. If everything stays within that 5% tolerance, your power supply is ready for a build. And here is our switching power supply, the heart of the PC. This label shows us total wattage and critical voltage specs. Sprouting from the unit is a variety of cables designed for specific hardware. Let's break down the most common ones you will encounter during a build. SATA power connector. This thin, shorter L-shaped black connector is used to provide power to modern hard drives and SSDs. Molex connector. While less common today, this larger 4-pin connector is used for older peripherals or case fans. This massive 24-pin block is the main ATX power connector. It plugs directly into the motherboard to provide the primary power for the system's logic and basic operations. And next, we will look at 4-pin 12-volt ATX connector. This provides dedicated high amperage power specifically to your CPU. You will find this corresponding socket located very close to the processor socket on the motherboard. We need to replace PCU if it can no longer provide stable power leading to system failure. We also perform a replacement during upgrades, ensuring the new unit has enough wattage to support high performance hardware like a dedicated GPU.
it and all that. And then I don't even know if I need to put references in. Like, do I need to put references in, like, the description of each video, what references I've used?
But think about the sort of videos that you're making. You're gonna watch them on YouTube, they ain't gonna have fucking links to explain it.
Yeah, I know, I just meant an academic one. These are just short videos. I don't know.
Pretty much done the whole database in one day.
Yeah. I haven't even really touched it.
It's fucking annoying to do it.
I just put it on AI. I'll get AI to do it and just step by step guide. Follow it through that.
Yeah, I might need to do that.
Well,
because
I did put a note on my
Shut all
universal
over.
credit page saying
Yeah.
that I wasn't
I've
doing
made
it this
myself a
afternoon.
checklist, but I'm there like, oh my god, what do I even do?
I would put like
Because I'm actually
the
at college
database
today.
file and the assignment brief and AI, and it's like, can you check it? And it said it did.
Yeah.
Yeah, I mean, I asked my static lecturers, they would probably make
No, no,
feedback
any
in
time
relation
on
to
Thursday.
what that means. Do we need that?
No, you already did that.
Yeah, I did. I just didn't like that it was just sat there on.
Okay, thank you.
Just, I was like,
Thank you.
you know.
Bye.
What do we need to film now? This, RAM, storage